Good morning, pre-algebra students. Once again, sorry I can't be with you. I'm hopeful that I'll be able to be back tomorrow, Thursday, but who knows? We'll see. Um, so today we're continuing with the last lesson of the chapter, lesson 5.5, and we're going to talk more about solving multi-step equations. We haven't even got to the inequalities yet. But just solving multi-step equations. And in this lesson, we're just talking about some special cases. And um, we'll just take these special cases by themselves in this lesson. And then after this lesson, these will kind of get thrown in and mixed in with all the other types of equations that we solve and everything. I hope that'll probably make more sense in a minute. But these look just like the equations that you solved yesterday. Some of them will have distributive property, a few of them will not. Some of them you may have to simplify first before you solve or whatever. But if there are parentheses, like we talked about yesterday, if there are parentheses, you have to do those first. And so we'll go ahead and work the parentheses. 3 times 2x plus 3 times 7 equals 6x plus 21. And so now we simplify this side by multiplying it. So 3 times 2x is 6x. 3 times 7 is 21 equals 6x plus 21. And in this case, this is why this is called a special case. Now, normally when we get to this point, and I'll just follow the normal steps that I usually do. Usually I would look at the variables first and ask the question, would I rather subtract 6x or subtract 6x? Well, obviously that's the same thing. So if I subtract 6x from both sides, then I end up with 21 on this side and 21 on this side because the variables have all canceled each other out. So the variables are all gone, and all I have left with is 21 equals 21. Well, of course, that's true. That is a true statement. 21 always equals 21. And so what we have here is an equation where the variable just doesn't matter. The variable can be any number we want it to be. And so we have a special phrase for that. It's called all real numbers. All real numbers. And that's just a fancy math way of saying any number that exists, any number that we can think of or imagine, that number would work to fit in for the variable, and it would be okay. The equation would always be true as long as we have a real number in there. And so that's one of our two special cases, all real numbers. The next special case is represented by this equation here. So this one doesn't have any parentheses, but it does have two like terms on the same side here. So 3b plus 4b, I can do that. So on the left side, I've got 7b plus 6 equals 3b plus 4b equals 7b. And now, same thing I normally do. I look at the variable terms, 7b and 7b. And so I'm going to subtract 7b from both sides. Whoops, 7b. Subtract 7b. And then I would end up with, these terms cancel out, these terms cancel out. So I would end up with 6 equals, and on this side, 7b minus 7b is 0. So 6 equals 0. Well, that's not true. 6 does not equal 0. And so we call this one a no solution. No solution equation. And that means no matter what number I put in for b, there's no number that exists that I could put in for b that would make this equation true. Okay, so those are our two special cases, all real numbers and no solution. And we'll talk, I'll just work through some examples where we see each of these kind of pan out. And then towards the end, we'll talk about some strategies and just some thoughts I have on these two special cases. So we'll work through a couple of them together and just see what happens. So here we don't have any parentheses, but we have like terms. So a and plus 6a would be 7a plus 2 equals. On this side I have 5a and 2a, so that would be 2, that's a 2, not a z, 2 plus 7a. Okay? So now at this point, I want you guys to be comfortable looking at an equation once you get it to this point and being able to recognize if it's no solution or all real numbers. And in this case, I see that I have the same variable terms and I have the same constants. I have a positive 2 and a positive 2. I have a positive 7a and a positive 7a. And so if everything is the same, all the variables are the same, all the numbers are the same, then that's always going to be all real numbers. All real numbers, okay? And so what I mean by that is you don't have to do any more work at this point. You don't have to show any more steps. Like you don't have to subtract the variables or get it down to 2 equals 2 or whatever. But once you get it to this point where you see that everything's the same, then I'll accept that as showing all of your work. Okay, but you do have to get it to here first. You can't just look at this and do it in your head and think, oh yeah, that's all real numbers. So show me this, and then I'll accept it. All right, this one we have parentheses. So 4 times x plus 4 times 5. And that equals 20 plus 4x. So now 4 times x is 4x. And then 4 times 5 is 20. So 4x plus 20 equals 20 plus 4x. Well, there we go. That's another one that's all real numbers. They're the same thing on both sides. All real. And yes, you do need to spell that out. It's not that big a deal. You guys can do it. All real numbers. Okay. Let's look at another one. Once again, no parentheses on this side. That makes it nice and handy. All I have to do is combine like terms. 5b minus 6 equals. I have a 2b and a 3b, so 2b plus 3b would be 5b. And then 7 minus 13 would be negative 6. So 5b minus 6 equals 5b minus 6. Well, at that point, I recognize that they're all alike. All the terms are the same, and so all real numbers. Okay, let's try this one. So negative 4a equals negative 3 times 1 minus negative 3 times a minus 7a. All right, so that's negative 4a equals negative 3. And then 2 minus signs next to each other would be a plus 3a minus 7a. So that would be minus 4a or negative 4a equals 3 minus 7a. Well, negative 3 there first. And then a positive 3a minus 7a would be minus 4a. So now this is the scenario where I have the variable terms are different. The variable terms are the same and my number is different. And if the variable terms are the same but the numbers are different, that's automatically a no solution problem. So same variables, different numbers, no solution. Same variables, same numbers, all real numbers. Need to see that pattern, recognize it. Okay, let's do these last two and see where we end up here. So 8 plus 7x equals 8 plus 7x equals 8 times 1 minus 8 times 5x. So that is 8 plus 7x equals 8 minus 40x. 8 times 5 is 40. Well, now let's look at what we've got. We've got the same numbers on both sides, but I have different variable terms. It means I can do this if I, which this is back to that standard question that I usually ask when we do multi-step equations, would I rather subtract 7x or add 40x? Well, I'd rather add than subtract any day. So we're going to add 40x. Add 40x. And that would be 8 plus 47x equals 8. And now I need to subtract 8 to get it away from this side. Subtract 8. That means 47x equals 0. And then divide by 47. And 0 divided by 47 is 0. So x equals 0. We'll talk about that one again just in a second after we do the next one. So new equation. We'll talk about why I threw one that has a solution in with this lesson in special cases. So 2 times 1 plus 2 times 4p minus 6 equals negative 10 plus 8p. So that would be 2 plus 8p minus 6 equals negative 10 plus 8p. So now we have a positive 2 and a minus 6. That would be minus 4. So 8p minus 4 equals negative 10 plus 8p. So this one, I look at my variable terms. They're the same variable terms, but then my two constants, my two numbers, are different. So that should tell you this one is a no solution. Oops. If I knew how to spell. Solution. Okay. The reason I put this one here is because what often happens at this point is people get this. They get x equals 0. But that's a solution. That's a number. 0 is a number. But a lot of times students will get to this point and they'll get x equals 0, and then below that they'll write no solution because x is 0. That's 0 solutions. Well, no, that's the solution is 0. This one, 0 doesn't work, 1 doesn't work, 2 doesn't work. There's not a number that will work, so there's no solutions. Okay, so you need to recognize that and understand the difference between a 0 as a solution and a 0 solution. Does that make sense? I hope so. I can't see if you're nodding or not, or if you're falling asleep or whatever. But hopefully that example helps you there a little bit. So on this last slide, just kind of talk about the rules. These are not to solve. These are just to look at. I wanted to show you what it looks like. If you have a no solution equation, this is what you'll see. You'll have the same variable terms. Okay? Same variable terms, and I'm going to put that right here, same variable. And again, it would help if I could spell, and if my pen didn't glitch. Variable. I think that's good. And then you also have this. You have different constants. Okay, different constants. So same variables, different constants, always point you to no solution. Okay, that'll always be the same. But then for all real numbers, I've got the same variable terms once again. So same variable. But this time I have the same constants also. So same constant. Okay. Same constant. So if you have the same variable and you have the same constant, that's always going to be in all real numbers. It won't matter what else you do after that point, it's going to come out to be all real numbers. So then, for this lesson today, most of the problems that you'll work on the assignment today are going to be either no solution or all real numbers. I did throw a couple of them in that have the solution is 0, just like that last slide. But after today, after we work through this lesson, and you kind of get the idea of what all real numbers and no solutions look like, most of the things that we work are always going to have one solution. I mean, that's kind of the whole point of math. We're looking for the solution, right? And so you need to recognize that, and recognize that just by looking at the variable terms. I don't care what the other stuff going on in the equation is. If you have different variables on each side, different variable amounts, then you will always have a one solution equation. So this is different variable values. And with different variable values on each side, there will always be one solution. Okay, it's not a terribly long assignment today. I think 12 or 14 questions maybe. And so you should be able to get a lot of work done on it. Remember, same deal with, as always, if you take it home, no more than 30 minutes on an assignment, bring it back and we'll work on it when we get back. So be ready tomorrow, Thursday. Hopefully I'll be there, and we will go over both of those lessons, both of the assignments that I've given you yesterday and today, and we'll kind of use that as a review day to see how we're doing. All right. So hopefully see you tomorrow. Thanks, guys.